Hello YouTube. Hi, this is Fahad and we have another laptop today. It's a MacBook Pro. The model number is A1278 and the board number is A20-3115-B. The problem with this laptop is very strange. It does power on. I hope you could see in the camera. Oops. Yeah, see, it does power on. However, the customer has been complaining that it heats up in some areas and it freezes. So let's investigate, let's check what happened to this laptop. As for the initial physical examination, I can tell that it has gone through some moisture damage. It's not liquid damage, but there is some moisture been in this board. Then I can see some corrosion on some of the test points, so we will check them and we will see where the heat is generating from. Let me check this board out first. So I'll take this screws off, flex is off. Okay, so it's a fairly old MacBook Pro, but customer wants to have it fixed, so we will fix it. I mean, as it powers on and he can use it for like 5 to 10 minutes as well. That is why he wants to fix it, and we will fix it. And it's quite promising as well, you know, like when the laptop is powering on all the way through, so we can just check what the fault is. If it is completely dead, badly liquid damage, I would be reluctant maybe, but this looks quite good board. Nothing major has happened on this board, so let's check it out. Okay. So let's do a physical examination of this board first, and maybe let me take you to the microscope. So the microscope is off. Just try and activate it. Properties, microscope, deactivate, activate. It should come up. Should it not? Come on, microscope. Okay, so the microscope is on. I just paused the video for a bit. Just wanted to make sure it was taking a bit longer to. This is the maximum zoom out I can do. Okay, let's check the board first. Okay, I'll take this off as well. Speakers. Okay, here's the board, and let me just adjust it for myself. You can see this here. Okay, the first thing, okay, there is some gunk here, and I think it's a flux, so most likely someone has already been in this board. Someone has tried to fix it. Okay, some more flux. Okay, this is something here. It's just kind of like a glue kind of thing, and we'll check this area. Okay, let's check more. I'm just doing a physical examination where if something is exploded, burnt, so I can just pinpoint it and I'll take it from there. You can see in near these edges there is some corrosion. There is some moisture came in this area, and it has not damage to any of the ICs by the looks of it, but we'll check more later. Okay. Here. So the good thing is it does power on. Alright, I can see some moisture, some flux here also. I don't know if you can, I'll just focus it a little bit more for you guys. Okay, now let's start from this corner. This, so there is moisture came in this area. Okay, these parts are badly corroded, but I don't see any liquid here. They are corroded because of most likely the moisture. There's no liquid marks on this. I did see some flux here, so someone has worked on this area before. Okay. So there is nothing like major burns or burnt parts on this board. Okay, let's inject the power and let's try and feel where the heat is coming from. So my power supply is set to, I'm going to this camera now. Okay, this is my camera. I'll just reduce my, okay, I have a zoom issue maybe. Let's check.
It's been a while before you.
Okay, let's inject some power. My power supply is set to 14 volts and 3.5 amps. So let's check it. Let's put the power in. I will connect the fan also. And where is the fan now? The phone goes like this. Just connect the fan. I'll try and feel the heat where it's coming from. So power on, the power. Okay, it's not drawing anything. Now it is. Okay, it's drawing 1.2 and 920 milliamps. Fan is spinning. This board does power on, so it's drawing enough power, but there is some leakage somewhere. Okay, I can feel heat in this area. Yeah, I can feel it here. So I'm feeling heat in this area. So it's drawing, like the fan is spinning really fast now. So, and that is probably what the customer was complaining about. Okay, this area is heating up here. Okay, these caps are hot, these 3 caps. Let me check this off now, power. Okay, so we know that the damage is in this area. Something is wrong here and here. So let's check this closely. What is here? Okay, I'm going in the microscope now, and in the microscope I can see there is some, oh, there is a solder ball. I just saw a solder ball. There is a solder ball here, just a small tiny teeny, and there is some flux. Nothing physically damaged. but this area has taken all the hit. Strangely, this was not heating up. These caps were. Okay, let me just clean this. Let's see. Okay, so I can see something is wrong happened. Something wrong happened here. These caps, and I'm quite sure these caps are connected. This buck converter supply is connected to the after the coils, and they are connected to the V core. Okay, let's see. Let's check them in the Flex BV software, the Paul Daniels Flex BV. Let's open it. I'll take you to my desktop now. Open the file, this one, the board view file. Okay, so we were detecting something here in this area, so I will just adjust it and I will check it in the schematics to find out which part is this. What it does, I just adjust it. Okay, it's a Q7100 and is a dual MOSFET. Okay, so it's an N-channel dual MOSFET, and it is connected to U7100. And U7100, if I check U71, okay, okay, this is the same place behind this dual MOSFET. This IC is controlling this dual MOSFET. So this IC was heating up, this area was heating up, and this area is heating up together. So there is something wrong between these two ICs, which is one is the ISL 95870A is controlling IC, and the other one is a dual MOSFET. So let's check the controller IC for this dual MOSFET, and let me take you to the microscope. Where are we? Okay. Right, yes, I can see some flux here, so someone has worked in this area before. Okay, I will just do one more test with the isopropyl, and let's see if this is where it's heating up. I'll connect the power. It's drawing the power now. Is it? No, it's not. Okay, it is now. Okay, let's see if this is the area, if this is where the heat is generating. Oh yes, it is heating up. So someone has worked here before, but because I could see some flux here, there's definitely some heat here. There's a lot of heat here in this area. Just disappears straight away. let's check if any of the capacitors are short. So my multimeter is on now, and we will do some testing on these capacitors, and we'll check if any of them are short to ground or any of the resistors are short to ground. Okay, that's fine. That's fine. Okay, there is nothing on these. This is fine. This could be a data line capacitor, so we'll check this one. Which one is this? Oh, it's not beeping, this cap. Okay, let's go back. Let's check this area. Okay, there is only one cap here. Ground check. Okay, this one is beeping both sides, but okay, no, it's not. So it's over limit, and there is some resistance. That's fine. Okay, this one. Okay, it's not reaching it, so that's fine. I'll just get rid of this cover. So this is not beeping. This coil is beeping. It should beep with some value, so that's fine. Okay, that's the dual MOSFET. So with this dual MOSFET, how many pins are ground? That's something to look at. Okay, we have one pin that is ground on this dual MOSFET. So if you can check here, I'll just share the desktop. If you look here, so this is the only one ground on this dual MOSFET. So we'll check this. If there is any more legs of this dual MOSFET, they are short to ground, we'll check them. But one more thing, I'm just thinking, if it was short to ground, there should be some shortage shown in the power supply as well. Okay, well, anyway, just check this. This pin is okay, these pins are beeping, but there is some resistance, and this resistance should exactly be same as the one in the coils, or not. Okay, that's fine. 18, 18, 19, 18. We're looking for one pin that is ground. Okay, where is now? This is like 18, 17, 18, 19, 19. So I'm quite sure this area is ground. They are ground. Yep, this is complete ground. So these three pins are connected to this pin, and they're all ground. So well, let's check this cap as well again. This cap is fine. Okay, so we saw one cap near this controller IC which was not beeping, so we'll check that cap. What is the story behind that cap? Why is it not beeping? Is it so? This was the cap, and here just open it. Okay, this cap was not beeping, so this one was not beeping. Which cap is this now? We need to check on the Paul Daniels board view software. Let's check it. Okay, so if this is the pin number 1, we have a coil. Okay, let me just share the desktop in this screen also, because then you could see both these screens. Just give me a sec. Okay, let's check the Paul Daniel software, and I'll take it to the desktop. So this is the IC we were talking about. Let me check which number is what. So I'll just turn this board around. Okay, so this is the cap C7130. This is that cap, and it is not connected to ground. However, something is strange. Where is it gone now? Here. Okay, so we have one resistor here, R7130, and on top of this there is a C7130. However, if you look into the microscope, this is the microscope. Come on. Yeah, okay, so this is our oh yes, I can see something is not right here. You see this cap here is supposed to be connected to this point, because in the I'll show you again, in the software you can see this is the resistor R7130. This is the resistor, and after that this is one cap is one capacitor is here. C7130 is connected to this pin VCC-SAS0, and this is connected, in our case it is connected to this test point. So they are, I mean, like, they are one thing. So the cap is connected from here to here. Okay, again let's go into the microscope. You can see that. So that's why someone worked here and he could not fix it. So probably he went for a water damage or something to clear the water damage, and he just could not put this cap properly back again. So this could be our guy, this could be the problem. Okay, let me just make it straight first of all. Okay, put some flux, put station on. Temperature is again 420. It's got some extra solder already here and here also. You can see some junk here in this corner. I'll try and clean it. So we found a culprit. We are not sure yet. We will just fix this first and check if there is still heat in this area. So temperature 359. I need 420. Okay. Come on. Oh yes, it's melting point now. Just adjust it. So the cap is okay now. Okay, let me just cool it down. Feel it a little bit. It's cooling down. Okay, let me just check what is here. Wow, there is so much dirt here. So the pins look good. So just give it a good wipe. The pins don't look bad, but this area, it has flux all around. This area has flux, so someone has worked on it before and he could not put that cap back on properly. We just clean it, give it a good clean. It will just cool the board down a little bit also. It will help to cool it down. This looks better now. Okay, let's check it now. If the board is still heating up or something changed after we put that capacitor properly. Okay, sorry, I'll just adjust this fan first. No idea. Yes, I think the fan goes like this. And let me take you to the bigger cam. Yeah. And let's check it now. Okay, no power. Oh, it powered on now. So is it taking any ampere? Nothing. Okay. Let me just power it off. Power on again. Connections are okay. This is a bit loose, this one, red one. Okay, so there was too much heat in this area. Okay, right. Okay, let me just check this. Let me just take you to my face cam now. I want to show you something here now. If you look at the milliamp amp meter here, the voltage that this board is drawing now, this should change also, because before we were taking 1.2, 1.4 when the board was heating up. If that has changed and the board is not heating, that's our clue. That means the board is okay now. So okay, 879, 875, 858, 1.0. okay, 1.01. you see it's not reached to 1.2 yet. So 685, the board is not heating up too much. Okay, there's a normal heat on the board. Fan is still spinning, so we did not reach to 700, 1.2. so we are at 700 now. The fan is spinning really fast now. Okay, okay, this area was heating up. It's not heating up that much still, so the heat is gone. It's not heating up anymore. Okay, let me just check the other side of the board. Okay, so the area that was heating up, these caps were very hot. Let's check them. Let's check them now. Okay, and it's fine. It's looking good. It's not heating up too much. I couldn't touch it before. So this area is not heating up either. This is normal heat. Before it was so hot I couldn't place my finger more than 2 seconds. Now there is heat, but that's quite normal. The fan is spinning. Okay, we saw one thing that was wrong, we fixed it. Now this is a temperamental kind of issue where it is freezing once it's powered on after 5 minutes or 10 minutes. So we will check it on the board. We will leave it on the test for some time, but on the power supply here it looks good. It's not reaching to 1.2, which when it was when that capacitor was put wrong, it was reaching to 1.2 milliamp, which is not going there now. So you can see it still is the fastest fan spin is still just 950 or 947, so it's not reaching to that limit yet. So I'm quite happy with this one, and we'll check it later on. That's it for now. Thank you for watching. I hope you learned something with this video. If you liked the video, like and subscribe the channel and leave some comments. If you want to if you have some questions, you can leave in the comments below and we'll try our best to answer them. Thank you very much.